Actually, it's exactly at 5 now.
Yeah,
Yes,
5:01.
and there may be some problem with him and we should start now.
Yes, yes.
Very good evening to all of you. Esteemed speaker here, Professor J.D. Jadhav, and all other fellows of the National Academy, Professor Basu, Professor Mahapatra, and the participants to this distinguished lecture series. Bhubaneswar chapter is a very small chapter of INAE. So this chapter has joined hand with SOA University and IMMT Bhubaneswar, and I hope actually very soon IOC ICT campus also will join with us. So with this, we are organizing few activities, and one such activity is that every month 1 or 2 distinguished lectures actually we are organizing, and today is actually 5th one. And if everything goes well, possibly in December 2022, we'll be organizing the National Convention of INAE and also the AGM here in Bhubaneswar. We are only looking forward to that. So with just a minute. Hello. आप join करना चाहेंगे कि? Okay. Okay. I'll manage. Okay. Thank you. So, friends, Mr. D.P. Mishra was supposed to join and he was to take over from me, but due to some problem, he's not able to join. So now I have to really play his role. I have great pleasure in introducing Professor J.D. Yadav, who is a fellow of US National Academy of Engineering, fellow of National Academy of Engineering, National FNA, FTWS, FASC, FNASC, FRSC, and everything. And what is most important, I have great pleasure in saying that Professor J.D. Jadhav has brought laureates to this country because he is currently an emeritus professor and of eminence, professor of eminence, and he was former vice chancellor of chemical engineering at ICT Mumbai. And the most important thing is that he has been elected as a fellow of US National Academy of Engineering in this 2022. It is really a great honor, Professor Jadhav. And also, what is interesting that so far as the fellowship of US National Academy of Engineering is concerned, only 22 people so far from India have got this honor, and 18 of them are living. And I'm told at least 5 of them are actually from ICT Mumbai, including Professor J.D. Yadav. And the others this year who have joined him to get this rare honor are your Elon Musk of Tesla, N. Chandrasekaran of Tata Group, and Satya Nadella of Microsoft. And previously, Mr. Ratan Tata, Narayan Murthy, and Kiran Majumdar Shaw got actually this honor. This is really a great honor, not only for you, but also great honor for all the fraternity of engineering, including Indian National Academy of Engineering. Professor Yadav was awarded the Professor Jayakrishna Memorial Award in 2021 for his outstanding contribution to engineering sciences. He was awarded Padma Shri in 2016. He has received more than 125 honors and distinctions and fellowships of Indian Science and Engineering Academies. He serves as independent director in a number of industries, including Godrej Industries, Bhagaria Industries. And he is also associated with many decision-making national bodies related to science and technology. He has so far has done 77 industrial consultation projects, and all his research that he has done in last 20 years have been supported by industry. This is a unique feature of his the type of research actually that he does. He has been one of the top 22% of the scientists recognized by Stanford universities. Now, he is a chemical engineer, but his research and other fields are related to catalytic science and engineering, which is considered to be a part of this physical chemistry. His research productivity is phenomenal. He has supervised 107 doctoral and 135 master's theses and had 47 postdoctoral fellows, which is a record for any engineering professor in India. He has published 498 original research papers, 115 patents have been granted to him, 8 new patents is applied, 3 books he has published. His age index is 64, and he has got 14,500 citations. And most important thing so far as actually Bhubaneswar is concerned, he is the person behind creation of this ICT, Institute of Chemical Technology and IOC campus here in Bhubaneswar. But for his initiative, it could not have been done. And possibly this is the only institute which is supported by industry. Indian Oil is contributing 500 crores for this campus to come up. And Odisha government has given, let us say, 100 acres of land. And very soon we'll see this campus, bright campus here in Bhubaneswar. So all great, Professor Yadav. So now actually I would request Professor Mahapatra, the Vice Chancellor of SOA University, to speak a few words about this university. And SOA is one of the co-sponsors of this lecture series that we are organizing. And our INAE office is also located in SOA. Okay. Professor Mahapatra, please. Professor Mahapatra, are you able to hear me? So possibly.
He was there some time back.
He is very much there. I can see his photograph. I can see him, but
No, this may be
you
a
are
static
mute.
photograph.
Professor Mahapatra, you are mute.
No. This is a static photo. This is not moving. So this is a static photo.
No. Here it is shows it is mute.
No, he is mute. The photo is also static. He is not moving. So the photo is not moving. I do not know whether he is disconnected suddenly. I do not know, or he has moved out.
So please, we'll again come back to him. So I would request Professor Basu to say a few words about IMMT Bhubaneswar. Please go ahead, Professor Basu.
Good evening to all the delegates, respected Professor Damodar Acharya, respected today's chief guest and chief speaker, Padma awardee, Professor G.D. Jadhav, and all the delegates, the fellow members of INAE, and the delegates who have registered for this webinar that we are organizing today, which will be delivered by Professor Yadav. This is a distinct honor for me to speak just before Professor Yadav to talk about my institute, and we have been talking to him for a long time that he should come and give a lecture, and today is the day it is happening through webinar, but this is a small token of appreciation that we are doing through INAE chapter. But obviously we want to do a large program, a big program, a physical program at IMMT auditorium or in the IMMT auditorium or in SOA auditorium as a big program of INAE and other program where I'm sure Professor Yadav will come and give a lecture. I know him for a long time and he is really kind and helped all of us in many occasions and many ways. And here he is today. I'll just take a few more minutes to tell all my delegate members here that this is a CSIR institute, which was known as RRL Bhubaneswar earlier and renamed obviously for good reason as Institute of Minerals and Materials Technology in 2007 because the deposits of minerals in Odisha and adjoining states is highest in India. And we work in the area of mineral processing, which is one of the forte and which is, of course, connected to a lot of unit operations of chemical engineering and and solid handling. And then we work in the area of extractive metallurgy. We have a division of hydroelectrometallurgy, which is very important, and not many institutes in India who are working on extractive metallurgy these days. And ours is the one institute which is a very good, well-equipped hydroelectrometallurgy department where we work on non-ferrous metal extraction. And in mineral processing, we are mostly concentrating on mostly ferrous and also non-ferrous. Then we have advanced material technology, where we work on materials and metal development, alloy development, pyrometallurgy, and powder processing, coating. We have a material chemistry division where we work on functionalization of the material application in devices, energy storage, and other. And connected to all these, we have a very big department of environmental and sustainability, which is very important in the area of mining, material, and metallurgy, where environmental issues are a big one and we need to obviously address. So we work on generic the solid water and air pollution, as well as we work on the mine area, reclamation of mine, how to manage the tailings, how to work with the industrial wastes and things like that. And then we implementation and modeling and project engineering and so on and so forth. So we are very much connected to industry, and we do all work with the industries within India, abroad as well. And we have about 250 regular staff and another 200 work as a contractual staff. And we generate a lot of funding through industry. With this, I'll hand over, and we are very happy to host, because this is we do every month we do a couple of seminars from INAE chapter. And all these seminars being hosted by SOA, INAE Bhubaneswar chapter, and IMMT, all three institutions together. And we do it every month, and we are going to increase the more and more frequency. We have a good participation, and today we are happy that Professor Yadav has agreed and come, and in this forum he is going to give his talk. And with this I end, and I request Professor Acharya to take this forward.
Okay, thank you, Professor Basu. Now, our VC, Professor Mahapatra, I think he's due to some technical reason, he's not able to get connected. I request Professor Mahapatra, are you here?
Yes.
Yes, he has joined. So, Professor Mahapatra, sorry, you got disconnected.
Actually, this was net was not coming. Anyway,
Now
good
please you
evening,
say a few
everyone.
words about our university.
Anyway, this is ground reality of the accept or don't accept doesn't matter. It says the world say there's nothing bigger liar than the country like India. So we have to be honest. So anyway, doesn't matter. Good evening to everybody. Professor Acharya, Professor G.D. Yadav, Professor Basu, all our deans, Professor Renu Sharma, all the participants and friends. I think 2 day lectures is great and commendable. Dr. Acharya has been doing a good job and we have very good speakers and good subject. And regarding the university, almost everybody knows, but today we had a freshers of 250 medical graduates. We had all our chancellor, pro-chancellor, vice-chancellor, pro-vice-chancellor, everybody was there. All the students had come with their parents. So it was a wonderful experience. We had 250 medical students taken. And coming to our university, probably everybody knows what I want to highlight. We have added to the liver transplant, bone marrow transplant, kidney transplant the last 3 years. We have added the medical technologies, which is lab technology, radiological technology, OT technology. All of you have observed that we had ventilator but no technician. We have ICU without ventilators. We have ICU without oxygen, ground reality. And we are deficient. We have produced 7.5 lakh doctor in last 75 years, while we take 1.7 million engineers. So bad health, poor infrastructure. So there's nothing more to talk about because we are below in the world 108 countries. We are below 10. Only countries below that is Ethiopia, I think Iraq, Afghanistan, Congo, something like that. So if you really go to any medical college hospital, now we are talking to take 23,000 medical students. Today somebody came and asked me, what's your opinion regarding taking these Ukrainian boys in the medical college? I say, very nice, because the government did not make medical colleges. We have to compromise. Our students have go out. We are superpower. But now imagine only 50,000 getting in 5 years. 15 lakhs and 550,000 did not get. And multiply 5 times. That's about 80 lakhs people did not get in 5 years. And these 25,000 people have gone out. So when you talk about injustice to 25,000 students coming from Ukraine versus 80 lakh students who did not get in that period, then you realize how bad is our medical infrastructures. Question is that what can you do? It cost 400 crores to start a medical college. You wanted dedicated teacher. The government has created 23 AIMS, but 50% faculty are vacant. Out of 23 AIMS, 10 AIMS do not have director. The AIMS Bhubaneswar, AIMS Assam, the person sitting in Hyderabad do the director job, he comes once a month. So when you think why the doctors are not working, why doctors are not available, out of 80,000 students we took this year, there are 37,000 postgraduates and 5,000 super specialists. So when you talk about gap, medical gap, we are deficient by 12 lakh doctor, 20 lakhs nurses. And if you look at the specialties, not super specialties, medicine, surgery, gynae or pediatrics, we are deficient between 68% to 82%. Go to the website of MCI, see the gap of 25th April 2021, then you realize where does the ICU, is our healthcare in ICU or without oxygen, without manpower? It's not oxygen, manpower. We are really very bad infrastructures. You create medical college, whether IIT Kharagpur or AIMS Bhubaneswar or AIMS Hyderabad, story all the same. In 10 years time, we have not been able to fill up the faculty post at AIMS Bhubaneswar. Half of the faculty posts are vacant because people will not come for a job which give you 1 lakh rupees after spending 1 crore for a medical seat. So when you feel proud that your student get a package of 50 lakhs, I feel depressed that if you go to the website today, 25% doctors do not have job, they are unemployed. 50% posts are vacant. 68% to 82% specialist posts are vacant, and we are deficient by 12 lakh doctors. So this is ground reality. You accept or don't accept. I am really in a medical profession for 50 years. It demoralizes me whether it's Ukraine or India or Ethiopia, doesn't matter. Choice is yours. What do you want? Health or money? Health or money? I think I should stop here because being a medical profession, my responsibility to see that you know the ground reality. Do not only fly in the sky. Sometime when you sick, go to casualty, realize how bad is the infrastructure. Thank you very much.
Thank you very much, Professor Mahapatra. With all your experience, you have really opened our eyes, and we are now exposed to the reality of medical profession. Now,
Dr. Acharya, good evening.
hello.
DP Mishra, sir. DP
Sir,
Mishra,
yeah.
sir.
Hello.
Dr. D. Mishra joined through mobile possibly. Dr.
Okay.
D. Mishra joined.
Good evening. So,
Good evening.
So I have actually done your job of introducing the Professor G.D. Jadhav.
Very good.
If you
Very
are his very close friend, please actually speak a few words about him, and then we'll request him to give his lecture.
That is, I wanted to introduce properly Dr. G.D. Jadhav. Good evening.
Good evening. Good evening.
Dr. G.D. Jadhav, Ganapati Jadhav. He is very close friend of mine, and we are both chemical engineers. I may be a few years senior to him, and but it's always a pleasure to have Dr. Jadhav, who can speak from Om to Janam actually, and as he claims himself, he is the former Vice Chancellor of Institute of Chemical Technology, and thanks to his efforts, Bhubaneswar could get a campus of Institute of Chemical Technology, and is the I'm extremely proud in this achievement, and because there will be chemical engineers from Odisha by the vehicle of Institute of Chemical Technology, they would get the world recognition which Institute of Chemical Technology always helps their students, because they are all everywhere in the world actually, and signing every part of the world. And so Dr. Jadhav really needs no introduction, because he is, besides being a established chemical engineer and having a mammoth knowledge on the subject, he is also, the government of India has bestowed Padma Shri on him, and many more laurels to come in the years to come. And so I would invite Dr. Jadhav to give his speech to our Indian National Academy of Engineering, Bhubaneswar branch. Again, thanks to Dr. Acharya. This is being organized very regularly, the speakers, speeches. And so on to you, Dr. Jadhav.
Thank you very much.
Professor Jadhav,
Uh,
may I now request you to give your lecture? The
yes.
title of his lecture is Achieving Sustainability and Net Zero Mandate through Adoption of Hydrogen Economy, Carbon Dioxide, Refineries, and Biomass Conversion. Professor Yadav, please.
Yeah. Thank you so much.
These things are perfectly visible.
Visible, no? Yeah, okay. Thank you very much, Professor Acharya, for inviting me to give this distinguished lecture on behalf of INAE Bhubaneswar chapter. I must also thank Professor Mahapatra and Sri DP Mishra, and of course my good old friend Professor Basu, and other distinguished colleagues here. Well, Professor Mahapatra told us about the situation of medical profession here. The engineering profession is not different. We are producing a lot of engineers from very good institutions, but the quality overall of education has gone down, and that is, because of the government apathy. But in case of medical education, I'm surprised that we took so many years to establish additional aims and not finding faculty. Okay, that's not my subject, but what I'm going to talk about is how do we attain sustainability, because the global oil reservoirs reserves are going down, the gas is going down, coal is going down, and we have to, have also this so-called net zero mandate by 2050. So where does hydrogen economy fit? How do we handle carbon dioxide and biomass? Okay, that is the topic of my, discussion. So if you recall, Paris Agreement of 2015, because of the United Nations, Convention on Climate Change, some 195 nations decided to combat climate change. And they had different numbers. They said, should it be less than 2 degrees and preferably 1.5 degrees? And can we achieve the so-called net zero carbon emissions by 2050? That is what they decided. Believe me, United States was not signatory to this. Then during the presidential election in the United States, Mr. Joe Biden, who is currently the president, was talking about net zero by 2050. So after he got elected, he had this leaders summit on climate last year. And what they decided? They decided to accelerate actions to address the climate crisis, including emissions, the reduction of these emissions, finance, innovation, job creation, everything, because many times people relate this to loss of jobs. Our Honorable Prime Minister Modi also participated in this. But fact of the matter is that if you look at the historical burden of, this carbon dioxide emissions, typically we take a starting date of 1750 when the industry started coming up. Okay, so during 1750 and 2018, how many billion metric tons of carbon dioxide has been emitted? Okay, United States would top the list, and that is 397. This has gone up substantially. Then China, Russia, Germany, UK, India stands at number 7. So India is also, a responsibility to reduce carbon dioxide emissions and also participate in the so-called climate change. So what happened in Glasgow? The so-called COP26, you see that India committed to have net zero by 2070. So my question is, why not 2050 like all others are saying? Is it that we are not sure of our technology, or because we are a very populous country? My answer is that India will achieve it before 2050. But anyway, that is what the government has committed, to be on safer side. But look at the carbon dioxide concentrations. In January 2020, just before the pandemic started, there was a 410 ppm CO2. Within a year, although there was a slowdown in economy, it added 2 more ppm to that. And now it is about 419 ppm. That means carbon dioxide is going out in atmosphere, and we are committed to 1.5 degrees C. What is believed that if there is no technological intervention, then the temperature may go anywhere between 6 to 8 degrees in another, 150 years. And that would be disastrous, because 6 to 8 degrees means climate change of extreme kind, floods and droughts and rains and whatnot. That is going to happen. But what was the reason for that? That is because our entire world economy is based on carbon. So if you look at the fossil carbon versus the renewable carbon, everybody knows of oil and natural gas and coal, and we are talking about clean coal technology and whatnot. Really speaking, these days refineries are talking about, crude to chemicals, C2C, like including Reliance Industries. And at the same time, underground coal gasification, clean coal technologies, coal to gas and coal to liquid. All these things are being talked about. On the other hand, in the case of because by 2054, we will not have any crude oil. Okay, the current technologies are not efficient enough to extract that. And now we know that, the oil today is about $130 a barrel. So it's very expensive. So renewable carbon, in the case of biomass, you can use chemical, biochemical or thermochemical conversions. And idea is convert that carbon into some form of, chemical or material. However, anything happens with the carbon, ultimately the fate of that carbon, when you use it as a fuel or otherwise, is carbon dioxide. So that means we have to take care of carbon dioxide. So I'm going to talk about that, the carbon dioxide refineries. But at the same time, this is not just a carbon dioxide problem, this is related to chemical and allied industry. Although in this, the contribution of chemical allied industry is much lower than that of a steel industry or a coal power. But I'm putting this slide just to bring home a point that can you show any 3 man-made materials or products without the use of chemicals? Okay. So whatever you are doing right now, you are sitting in front of a computer, you are relaxing in a chair or whatever, maybe using mobile phone. None of these products can be made without chemicals. So anything which is man-made has to use chemicals. So if anybody shows that any product is, without use of chemicals, man-made product, then that person can get 100 million pounds prize, which is waiting since 2008. The answer is no. So chemicals are very important. So in carbon dioxide or biomass, as a source of chemicals or feedstock, how chemicals are going to be important and how chemicals can be produced by green ways, efficient ways, that is what I'm going to talk. So in summary, energy, environment and climate change.
Professor Jadhav, Basu here. Did you share your slide with a full screen? Are you moving the slide?
Yeah, I am. You're not seeing it?
No, it is not. It is not full screen and it is not moving.
Is there a actually, I tell you, the other day also on this Microsoft Teams platform, I had this problem, and then I use without this thing. Can I rejoin?
You can use without full screen. Then left hand side you have to choose your slide. Yes, we are now in the 8th slide.
Yeah, I know. I'm on this slide, but no. But why the full screen is not seen on Teams? I have not understood that.
No, you have to share your window rather than sharing the PowerPoint. If you share the full window, then it will show.
Let me do that again. Okay, I will do that.
Share the whole window, not the PowerPoint slide.
No, I'll do that. I'll do that. So that is what I had done. But anyway, so this is desktop or window, and there I had shown.
Or share the desktop.
No, I can share the desktop. This is desktop. Okay.
And then anything on desktop, now it is coming, looks like. Yeah, desktop is shared. Now you open your PowerPoint.
Okay, I'll do that. Can you see this?
Yeah, now you have to make full screen possibly.
No, I will make it. I will make it full screen, but just 1 minute. Do you see it now?
Yes, now it is full screen, and if you move the slide, let us see whether it moves or not. We can see the full screen slide, but we have to now move it, then we'll know. Yes, full screen is seen.
Do you see the next slide?
Yeah, go to next slide. Yeah, it's working now.
Oh, great. Thank you so much. So I was on this. So anyway, I just, you should see this. This was my second slide. This was my third slide. This was my fourth slide. This was the fifth COP26. And I was talking about the CO2 concentration. And I talked about the carbon sources. Okay. And this is the one where I said that nothing can be made without chemicals. And so I said anybody who shows 3 man-made products can get 100 million pounds. Anyway, so what it means, energy, environment, and climate change are very intimately connected. Okay, we know that. However, one of the questions which we should ask, because we are talking about renewable carbon, is biomass good as an energy source, and is it new? Okay, and should it be used for energy? So I'm going to give you some counter arguments, points to think, and why I say that biomass should not be used for as a biofuel but chemicals. Can you see it now? Yeah, okay. So according to me, in our religion we talk about Trinity, Brahma, Vishnu, Mahesh, or maybe the Christians talk about Father, Son, and Holy Spirit. According to me, the new Trinity, which is a scientific Trinity, is solar, wind, and hydrogen. Of these three, hydrogen is going to give us chemicals and materials apart from energy as a source of energy or energy carrier. So let me give some idea. And I'm saying that hydrogen is going to be the savior of the world. Okay. On 17th of February, this appeared on the 18th February newspapers, Ministry of Power notified the green hydrogen and green ammonia policy. And according to the ministry, the implementation of this policy will reduce dependence on fossil fuel and also reduce crude oil imports, because that is the one which India is really worried about. And what the policy says that 50% of the country's energy needs should be by renewable energy. So by 2030. So let us look at it. So if you take carbon-based fuels versus hydrogen, and I mentioned earlier that whether the carbon is coming from fossil fuels or biofuels, there is a need to convert carbon dioxide into fuels, chemicals, and materials. Okay. And since hydrogen is the cleanest fuel, okay, and it can be produced from variety of sources, whether there is a carbon source, whether it is coal or alcohol or hydrocarbon, you can do steam reforming and get hydrogen. Okay, but the only problem is that it will have a carbon dioxide as a co-product. So how we are going to deal with this? So let me take you back a little bit to put in perspective my lecture, that why we have been so much dependent on crude oil, and since this war has begun, what has happened. So when your oil production, you have a primary, secondary, and tertiary recovery. Okay, so in that, what is happening? So in the primary, when you drill a well, there is a natural flow. The pressure is depleted, and then ultimately you have to have water flooding, or you have to maintain the pressure, and that is the secondary. So in the primary recovery, you get very little, oil, and the secondary recovery may be 30 to 50%, depending on type of reservoir. Now, all reservoirs do not give that, because there will be wuggy, cracked reservoirs and all. And in the tertiary recovery, we may have combustion, forward combustion, reverse combustion, maybe have steam, hot water, or gas injection, polymer, surfactant, microbes, and whatnot. We can do all that. This is what actually happens. So primary production will be anywhere between 10 to 25%, secondary 10 to 20%, and tertiary potential depends on what tertiary method you use. Okay. And by 2054, we will not have a proper technology to recover this remaining oil. That is the problem. So this is actually what they do. You have a gas cap, then the free gas, and when you say oil, actually it is not just oil. It is mixture of oil and water and gas. Okay. So this is always a two-phase flow, and sometimes it is three-phase flow. So what happens when you have the oil recovery? In the water flooding, that water is not clean water. You have to add a lot of chemicals in that. You have to add biocides and whatnot. And so long as the production well gets substantial quantity of oil, so oil to water ratio is very important. And sometimes if the water is too much, maybe, 50 barrels of water and 1 barrel of oil, it is not economical. So they abandon it. And that is based on some fundamental principles. And that is, so-called aerial sweep, say, vertical. I used to work in this area. In fact, I have patents also in this. Okay. So what happens these days, people are saying, if you have carbon dioxide and you are depleted wells, can we store this carbon dioxide, sequester there, and use it as a feedstock sometime later, or use carbon dioxide for taking out the oil which is remaining there, the oil in place during the tertiary recovery. Okay, that is the thing which is talked about. But as I said earlier, whether it is a petroleum-based industry or a biomass industry, in the bio-based industry, we talk about net zero, carbon zero. That is because the carbon dioxide is recycled through biomass in photosynthesis and whatnot. However, in the case of the petroleum refinery, the carbon dioxide just emitted. Unless we capture it by some means and convert into, make it a carbon neutral industry, it is not going to happen. So anyway, this is one of the problems which countries like India are facing. The farmers are burning their agri-waste because they think that will increase the fertility of the soil. It will kill the bacteria, kill the insects and whatnot. That is what they believe. However, they are treating it as a waste, but it is a wealth. And technology should be used to make wealth out of it. So you know that if you go to Delhi during December, January, it's always foggy, poor air quality, and flights are always delayed. You know that. That is because of this fog which is created by particulate matter and the carbon dioxide which is being emitted in the atmosphere. So if you instead develop technology, take agricultural residues and convert that into, for example, you do gasification, you get syngas, then Fischer-Tropsch synthesis, you can make fuels and whatnot, all sorts of chemicals. Or you have liquefaction or pyrolysis, you get bio-oil. The bio-oil again has to be upgraded where hydrogen is used. Okay, so refineries use a lot of hydrogen. Even in the case of this biorefinery, hydrogen is required. So whether you have xylose, glucose, lignin, you make all sorts of chemicals. Okay, that is what the farmer doesn't know. And one of the things is, if you are, for example, cellulose, hemicellulose, what chemicals I have shown here, all of these become feedstock for another set of industry. Okay, like xylitol, very important chemical, or 2,5-furan dicarboxylic acid, which is used for making, biodegradable polymers. Okay, or 5-HMF is another chemical which comes from glucose that can be used for variety of products. Yes, so what it means, if you have a source of biomass, whether it is agricultural crop waste, wherever there is a carbon, or industrial residues, animal residues, municipal solid waste, the part of that which is carbon containing, okay, an organic carbon, and then you can use it for making, including the sewage, for making chemicals and other products. So this is a very crowded slide. I won't go into that, but what I'm trying to tell you that any grass or any harvest or chop, whatever, you have to dry it, you have to compact it, you have to pelletize it, and then it can be used for a variety of things, whether it is fermentation or, enzymatic reaction. You can have all sorts of products in this. So ultimately what I'm trying to tell you is that in the oil refinery, we have oil, light oil, kerosene, naphtha, and petrol, and you have fuels, chemicals, materials. Okay, this is because we use these fossil resources. In the biorefinery, on the contrary, you may have gasification, saccharification, extraction, syngas, sugars like C5 and C6, all sorts of oils and fats. These again bioprocesses, same type of chemicals can be made. Ultimately, what is happening, this carbon dioxide here is going into the atmosphere, and that is what is the greenhouse gas creating problems. And here carbon dioxide, is, photosynthesis. It can be captured by trees and whatnot. So carbon dioxide, instead of becoming a liability, we should take it as an asset, take it as a feedstock and develop processes. And that's what I'm going to tell you. So another problem, this is discussed in one of my very, interesting papers, which has almost 7,500 accesses, and people have asked us all sorts of chemicals. should biomass be wasted on making low value, high volume biofuels? And across the world, including leading countries like United States and our country, India, they are talking about bioethanol and all sorts of things. And we have proved through, calculations and all. Bioethanol, well, yeah, you can say it is a carbon neutral and all that, it is okay. But actually, you don't get much money. So I'm going to show you through calculations how bioethanol is not giving us much money. So biomass should be converted to chemicals and materials and not be used as biofuel. Okay, so and then how do we have this net zero economy by 2050? So this is this is just to give a snapshot, because you may not be chemical engineers, but perhaps refinery. So you have boiling point rising from top to bottom, right? You have petrol, naphtha, kerosene, diesel, heavy oil. This is what the refineries do. And chemical engineers find a lot of jobs in this refinery, all mechanical, electrical engineers as well. So in the modern thing, if you look at the various processes, these are the processes. Why I'm showing them? Because all these processes, majority of them require hydrogen. And these are catalytic processes. And once they are catalytic processes, we talk about multi-phase reactions, all these catalytic processes. So you have all sorts of, reactors and designs and all that. That's the job of a chemical engineer, right? But I'm going behind that. So if I have a petroleum, natural gas, air, and sulfur, I can produce all sorts of commodity chemicals, secondary, tertiary, and finished projects. And what does the Janta need? Textiles, maybe food supply, maybe transportation, housing, recreation, communication. All that thing everybody understands. But if you go backward, you will find that there are so many things, the polymers and whatnot, okay? And the monomers. So normal people don't worry about this. What they are interested in the final product. And chemical industry is the best customer for itself. 60 to 65% of chemicals do not see the shelf because they are always used by some other industry. So that is what is. So nowadays we are talking about after Atmanirbhar Bharat. And we are importing so many APIs and all from China and other countries, for instance. See, it is easy to ban, products like, apps and all, but it is very difficult to ban the raw materials which your industry needs. So this is where Indian industry and the government of India has to, encourage our chemical industry to produce all these important, APIs and whatnot. So I'm coming back to the oil refinery versus biorefinery. Look at this simple picture of oil refinery. Okay. So in this oil refinery, there are processes where hydrogen is required. So how is this hydrogen produced in refineries? They normally take steam reforming of natural gas. Okay. So steam reforming produces hydrogen. This is called as gray hydrogen because it produces carbon dioxide, and this carbon dioxide goes in atmosphere. At the same time, hydrogen is also required by biomass, and I'm going to give you an interesting example. So if you have hydrogen produced from a clean source, that hydrogen is required to convert biomass into a variety of chemicals. So ultimately what happens in the refineries, you have cat cracking, hydrotreating, hydrocracking, catalytic reforming, HDS, HD, and all those processes. All of these are based on hydrogen. So hydrogen is required even now by the refineries. So even in future, suppose there is a reduction in, the crude oil, but still the processes will require hydrogen. So we require hydrogen, and biomass requires both hydrogen and oxygen to convert. So I'm going to show you that. So I'm having my firm belief that hydrogen is going to be the savior of the world. Okay, that is why I made a separate slide for this. So let us look at, I mentioned one figure, that is 2054. What happens in 2054? Remember, Mother Earth, the carbon crust is only 0.18% carbon in Earth. Maximum is oxygen, and in the form of oxides, and then followed by that is silicon. So if you look at the carbon dioxide emissions, this is BP Energy's outlook. BP Energy predicted, they showed this, that in 2020, around that time, we emitted 35 gigatons of carbon dioxide. And we are committed to 1.5 degrees C. That means the carbon dioxide emissions have to go down. How will they go down? Unless we have less carbon dioxide and replace these by renewable sources of energy, and there is a rapid transition. So in this transition, you can see below 2% or 1.5%. You see, that means we have to reduce the carbon dioxide consumption to less than 10 gigatons. That means 25 gigatons of carbon dioxide should go out of the fuel market, right? That is what it means. So in this particular case, the renewables, the share of renewables is going to go up, whether that is wind, solar, geothermal, biomass, biomethane, whatever, that is going to go up. And remember, one of the rules, thumb rule is that the electricity production of any nation shows the GDP increase, right? So suppose there is a 8% or 9% growth in electricity, that means our industry's GDP is also going to go up by that, because everything is dependent on electricity. And if you could produce electricity by clean means, that means you are protecting the environment, right? So what actually is happening, if you look at this, by 2050, the share of renewables is going to grow up, okay? And you see the crude oil will go down, coal will go down, but still in 2050, countries like India still will be using, or China for that matter, they will be still using coal. So it means that we have to look for the renewables. So one of the numbers which is very interesting, I'm going to make use of this number in one of my slides later, that in 2020, before the pandemic started, something like 97.4 million barrels of crude oil was used by the refineries. Okay, and that time that 410 ppm CO2 was there. So this crude oil is being used for all sorts of sectors like passenger cars, trucks and buses, aviation, marine, and non-transport is very important. The building industry that requires something like 33% of the energy. But normally people don't, consider that, but that is a very major chunk of my energy. And at the same time, the natural gas consumption is increasing. There will be some more additional reserves of natural gas which will be found. But the beauty of natural gas, if you use natural gas for example, for hydrogen production or make up chemical, carbon dioxide has to be taken care of. So natural gas is taken as a near zero carbon energy. So, and what it means, you must have a carbon capture and utilization and storage. So this is very important, right? This is very important. So if you are unabated, then that means 100%, and there is some net zero, you can see that almost something like 70%, is going to be carbon capture and all. So this is very important for us in talking. So in renewable energy, you will see that if you take that 2018 as the base price, this is the cost of this production of energy, or the wind and solar. This is declining day by day. Okay, this is declining. So that is growth, and there will be also geothermal in that. Okay, so if you look at the bioenergy and we want to go to net zero, see what is going to happen. So you see here the power, building, industry, transport, and these are this biomethane, biomass, biofuels, and hydrogen. So hydrogen will have something like 25% share. There will be about 73% share of renewable energy in the renewable sector. So, and the solar and wind capacities, because they will flatten afterwards. Okay, and so you will see that the investment will go down in this. So if you look at the hydrogen by type, so by 2050, we will have only green hydrogen and blue hydrogen. There will be no gray hydrogen. The gray hydrogen will be still up to 2035. Okay. So and the sectors which will be power, transport, building, and industry. So, and this data I collected from European Union, International Hydrogen Council, and Bloomberg New Energy Fund. Okay, and what it says, that there will be on an average about 8% CAGR, okay, and there will be $150 billion investment in 2030. So to achieve that, we have to follow hydrogen economy, and it has to be a reality. That means we have to produce hydrogen in an economical way and eco-friendly way. Then only the net carbon zero goal will be possible. So for instance, Okay, this is the International Association of Gas Oil Producers. What they say, we have natural gas for hydrogen, or they have gas reforming, in which will create carbon dioxide, hydrogen, and gas pyrolysis. In gas pyrolysis, you will have only carbon. So many times researchers are talking about carbon nanotubes and hydrogen. Okay, and then what it means that when you have a carbon dioxide coming as a process, the reforming process, steam reforming, it has to be captured and stored. Okay, that is what. And then the hydrogen can be used for a variety of things, that which I mentioned before. So now I can say that, so green hydrogen, blue hydrogen, and gray hydrogen, these are the three shades. We can convert them into 5 shades, and little bit later I will tell you that. So electrolysis of water, okay, including, so you have wind, solar, hydro, nuclear, because you require energy to break that water molecule, right? So green hydrogen is a gold standard, zero gas emissions. Blue hydrogen, you have steam reforming of any carbon source, okay, maybe biomass, bio oil, and whatnot, but carbon dioxide has to be captured, okay, that is it. And gray hydrogen, what the refineries are doing right now, the carbon dioxide is let go in the atmosphere. So, this blue hydrogen, okay, well, that is a part of that net zero, right? So you have natural gas and you convert, so long as you capture that carbon dioxide, you're fine, okay? That is because that is the so-called net zero. However, one of the things which they added, that is methane pyrolysis. So 1.1 ton of hydrogen requires something like $944, okay, based on this cost of electricity. This is US data. So it gives 1.1 ton of hydrogen and 3.3 ton carbon, which can be industrial use or it can be landfill. But this is one of the ideas, okay? People are talking about why not produce hydrogen by just pyrolysis, okay, of methane gas. So now instead of 3 shades, they are talking about green, blue, turquoise, gray, and brown. So instead of, natural gas, you use coal, and then you produce, or you get natural gas, you get gray. So instead of that, the gray, this is what I already told you about. But if you look at the cost of this hydrogen, because that is what is going to decide the future of hydrogen economy and the so-called carbon dioxide refineries, which I've been mentioning. If you have coal, for example, and without any carbon capture, this has highest greenhouse gas emissions, 19 tons of carbon dioxide per ton of hydrogen. And the cost will be anywhere from $1.2 to $2.1 per kg. Gray hydrogen, natural gas, which the refineries are doing now in steam reforming, it produces 11 tons of carbon dioxide, and the cost is almost in the same range. In the blue hydrogen, natural gas with advanced carbon capture, it has low, about 0.2 tons, but the cost goes up. That is $1.5 to $2.9. And the green hydrogen, it is a renewable electricity, doing electrolysis, and the electrolyzer costs are very prohibitive. So I'm going to talk about that little later. Okay, zero granules, but cost, you see, $3 to $7.5. And this has to be brought down to less than $2. Okay, that is the idea. So in other words, we are facing a dual challenge that we need more energy because population of the world is increasing, and at the same time we have to have less carbon. So how do we do that? Okay. So one of the things which is very interesting about the renewable energy, you see that, so about 18% of, share of renewable, during this time, about 2005, by 2050 it will be 73%, and see, major will be solar and wind. Then of course hydro, nuclear, gas, and coal. And what is believed that will be something like 49,000 terawatt hour energy for the entire world. But why did we go for carbon source in a carbon-based economy? Before that, many people don't know this, that, in North America during 18th and 19th century, they used whale, and these were called as oileries. So blubber of the whale was taken out, and from that they used to get the illumination, like we have kerosene, and then make soaps. So this is what they did during that time in North America. What happened subsequently, the population of whales dwindled and it came to some real extinction. So there people were worried, how are they going to have the energy source? So this is really a biosource. So if you call it as a biorefinery, this whale oilery, That term is not wrong. Okay. But the whale population was saved by advent of crude oil, and we must thank Edwin Drake, okay, who drilled. This figure is from my research paper. Okay, birth of the oil industry in 1859. But what happened? So accidental things happen in that is what is the story of history of technology, right? So he drilled this well, but then they use this for kerosene and heavy oil residue, but the gasoline or the petrol had no use. So they used to dump it in sea, rivers, and lakes. It had no use whatsoever. Thanks are due to Henry Ford in 1907. He introduced the automobile and petrol found use, the gasoline found use. And then the production and USA became the prominent oil producer, okay, accounting for something like 95% of the crude oil production. Remember, during 1920s, a lot of process evolution took place. Several petrochemicals were formed during that time. So all sorts of things happened during that time. That was the period during 1910s. The synthetic ammonia was also formed. Then nitric acid, then the nitro derivative, then the World War, all that you know. So after this, during the period of 1920s to 1940s and all, a lot of innovation took place in this industry, and one of them was the catalytic, cracking. So they use clays, acidic clays, as a Cowdery is the person we talked about. So catalytic, cracking was achieved, and because of the superior quality of the fuel, aviation fuel, the Allied forces that included Russia won the World War II against Germany. Very interesting. And there is a side story. I would like to entertain you with that side story. During that time, in the Russian army, there was a general called Vladimir Ipatov. Now also this name Vladimir is seen in the context of Russia and Ukraine. But this Vladimir Ipatov was a general, but at the same time, a fantastic scientist. He was a catalytic scientist, okay? He developed so many processes. What refineries are claiming now, platforming and cut cracking and all, that is due to that great guy, Vladimir Ipatov. So at the end of the war, the Americans literally wanted him. So he left Russia by train to Germany. He knew only two languages, Russian and German. He told his wife, "My dear, look at Russia. This is the last time you are going to see it. We are not going to come back." And literally they go to Germany, and the Americans offer him a job in UOP. That is, UOP is a great company. And this story I'm telling you, because it is given in the Ideas for Rent, their book, historical book of UOP. What they did, because he was also a colorful man, so the Americans not only took him and his wife, but his concubine also, because they were interested in his science, nothing else. And that is what happened. And you can imagine he was nominated for Nobel Prize, but he was not given because they said he was a military general. So sometimes history is unkind to great scientists, like it is unkind to our Mahatma Gandhi. So catalytic processes, real science, engineering and all, that was because of this refinery. So carbon-based economy and the innovation and the reactor design and the catalysis, all that is because of this carbon-based industry. Now the refineries are highly complex. We don't understand how they do it. Okay, so you imagine that in 2010, the global output was 70.3 million barrels per day. Okay, and global movement was something like 14.9 million barrels per day. Okay, that was the oil production and movement. So now what is happening? We are talking about biorefinery. So if you talk about chemical, the crude refinery, your gasoline, okay, petrol, kerosene, diesel, fuel, everything knows about it, right? And catalytic processes. In biorefinery, exactly opposite we are going to do. Here we are, functionalizing, benzene, toluene, xylene, naphthalene, butanes, and whatnot. That is our feedstock. Here we have a very complex mixture. All sorts of functional groups are there. We have to defunctionalize them, and then we go for alcohols, organic acids, phenols, furans, and whatnot. That is called biorefinery. And so in biorefinery, you have cellulose, hemicellulose, and lignin. And you make variety of these products, xylitol, furfural, levinoleic acid, and all those things. You know, many people are working in this area, including ourselves, and we have got few patents in this area. What is important is that the catalytic processes are responsible, even in the case of a petroleum refinery or a biorefinery. Look at the kind of things which we make from C5 and C6 sugars, you know, pentose and hexose, and cellulose and hemicellulose. All these are catalytic processes, whether they are ethers, alcohols, acids, and whatnot. And the remaining part, the lignin part, again, this is metal catalyzed reactions. You see diacid, syringaldehyd, vanillin, all those things. Benzene, toluene, xylene also you can make out of it. So in both these cases, hydrogen and oxygen are playing very important roles. So what it means, you know, water splitting is the best thing to convert this biomass into variety of chemicals and materials. So you say, for example, we have lignin and we have, you know, C1 to C5 oxidation, side chain oxidation. You see variety of these products are produced, and these are high value products. These are high value products. And then we are talking about biofuels, right? The first generation, second generation, third generation, you know, see that all these biofuels we are talking about, and we say that they will be carbon neutral, right? So what we did, we decided to do some analysis. Suppose we have a biofuel and we create this thing. What is the means by which we can take this, transport these fuels to pipelines? We could get data from, you know, United States, the Department of Energy, and North American data were available. We don't have those data in India and the rest of the world. But anyway, if you look at the oil refineries and the network of these and the bioethanol plants, you see which wherever they are, and this is funded by the US Department of Energy. Look at this, and the corn producing regions. These are the green ones. There, you know, these refiners talk a different language. They call it as a crack spread. That means if you crack crude oil, what is the, you know, spectrum of chemicals you get and what is the value? So that suppose crude oil is 130 barrel today, and if I make 160, so $30 is the crack spread. That is the language of a refiner. In biorefinery, what is the crack spread? So if I take 1 kg of, you know, crude oil, I produce 32 megajoules of fuels, current refineries, plus 0.2 kg of chemicals. And if, on the contrary, if I take 1 kg of biomass, I get only 6 megajoule of energy, or 0.8 kg chemicals. So if we extend this, and I gave a magic number of 97.4 million barrels per day, if we convert that, so this is 250 barrels per second. 100% biomass will give me only 10 barrels per second of fuel. If I convert that into chemicals, I get 320 barrels per second. What it means, it is better to convert biomass into chemicals and not fuels. So this we did analysis. In fact, when we wrote it, we wrote the paper for Nature, and you know, this Nature editor says you are talking this thing. But anyway, we published it later. But a lot of people asked us how we did these calculations, and they agreed with us. So that is a very interesting part of this, because we are also given some information about the failure of this, you know, Department of Energy's biofuels policy. Okay, we talked about that. Okay, successes are very few, more failures in the biofuel. And we also said, suppose we talk about methanol economy, which is a pet theme of our Niti Aayog, and Dr. Saraswati is a great advocate of that. And so if you have methanol, you can produce methanol from carbon dioxide. That is what we have been doing. We have got patents also. Or you can produce methanol from syngas. Maybe source is coal, for instance. Methanol economy, we can produce all sorts of chemicals, including hydrocarbons. Okay, we can including MTB, olefins, acetic acid, name it. So that is, methanol is a versatile feedstock. So in other words, we can use carbon dioxide and make many things. We can use methanol, make many things. So yes, the chemical industry will survive. Another important product, a problem which the Janta normally talks about, is the consumer plastics as waste. And there are 7 different types of plastics. I will not go into the deep details. You know PET, you know HDPE, LDPE, PVC, and polystyrene, and polypropylene, and rubbers, and butadiene, and whatnot. These can be waste, right? And government is worried about the plastic waste. So for example, the single-use plastic waste, should it be banned? Now this question I am asking and I am giving an answer also to that. So look at United States, then we look at Europe and look at India. United States, California, there is a ban on plastic bag, okay, single-use plastic, which is polythene. Then there is a plastic bag tax, you know, in some places, and there is a recycling. In Europe also, you know, some of these things are banned, some are allowed if the caps remain attached. Then drinking cups, they are asked to reduce the waste, and then you have cleanliness, cleanup awareness. And our government said from 2nd October last year, these are single-use plastics which have been banned in India. Now I'm going to give a counter argument. And in European Union, single-use plastic directive is there. Okay, they banned last year. They say design requirement 25% recycle content in PET. That means PET can be recycled, right? Depolymerization and all. And 2030, 30% recycling. Okay. Then you have to have a 77% single-use plastic bottles, caps, and this is in USA, Europe. In India, we have a lot of recycling of this. In fact, India has the maximum recycle of this PET bottles. 90% single-use plastic bottles with caps and lids by 2029. And what is the EPR obligation? All state must have this obligation. And so you look at the food containers, packet, everything. So they want to have a reduction in consumption of SUP. So what I'm going to tell you, is ban a solution for this? And my simple answer is no. Ban never solves the problem. In fact, ban creates more problems. Why not single-use plastic be properly collected and recycled? So I'm going to tell you the way how to do it. We look at this boy, because these American boys also in the morning go and distribute the newspapers. Even in India, we do that, anywhere else. So newspaper boy comes to your home and gives the newspaper, and your wife collects the newspaper and then it is recycled back, right? Nothing is wasted. Newspaper is not wasted. So I'm saying, supposing we have single-use plastic, arguments say, can we not have a deposit for that? Supposing it is a plastic bag and you say deposit is 1 rupee or 2 rupees. And in the morning, the boy comes and collects that plastic from you and gives you back your deposit, except 5% maybe he takes his, his commission or whatever, and he promotes digital economy. So that can solve the problem, because see, sorting out at source whether paper or plastic, consumers should pay some refundable deposit. Plastic boy collects it and charges 5% of the collection. In fact, I had suggested this to government of Maharashtra, but they would not listen to me. So why I'm saying that? Because waste plastic chemical recycling techniques are available, and they are very much there, like chemolysis, pyrolysis, gasification. So we have upcycling, downcycling, and conversion into many things. So the chemolysis and thermolysis, what it means? Chemolysis means it's a chemical reaction. You have hydrolysis, glycolysis, aminolysis, all those things can be done. Convert that polymer into something else. Okay, so it is all known. Hydrogen plays a very important role, because we can hydrogenate the plastic. And then because the industry already knows how to deal with chlorine, nitrogen, oxygen, sulfur. That is all. This is refineries already know this. So we don't have to do anything. So hydrogenation gives us many things to us. And we know this is the catalytic process. I won't go into the details, but what it means in hydrocracking, you create methane or some other, hydrocarbons, ammonia, H2S. This is the source of sulfur and HCl. So hydrogenation reactions are well known and well studied. So whether it is PVC, PET, polyamide, rubber, all those things can be taken care of. So instead of banning, if we develop that way, what it means that you must have the collection at source rather than dumping in your garbage and the municipality takes care, because 80% of the money is spent on sorting out. Okay. So because of this, we will have a lot of incentive to develop better catalytic materials and all that thing. We can do that. Okay. And why hydrogen? Because hydrogen is the cleanest and safest fuel. When the policy was announced on 17th of February, immediately on the Sunday, one of the economist journalists talked about the hazards with hydrogen. So I wrote an article, in fact, that will be published. I wrote for a newspaper, I wrote in vernacular language also. Hydrogen is safer than petrol, because many people won't believe it. But anyway, another polluting thing is the steel industry. Steel industry, China is #1, India is #2 in steel production. And steel, typically about 1 ton of steel will produce about 2.5 ton of carbon dioxide. And you see that India's production last year was something like 102.5 million tons, and this year it will be 120 million tons. So we are going to produce a lot of carbon dioxide. So what should be done? So you have, water splitting, maybe water electrolysis, and you get hydrogen clean. And so you can have all this steel industry, so-called green hydrogen, green steel. Okay, that same case applies to, for instance, nickel and some metals, where they are from the oxide form, you bring them to the metal form. Okay, so in the case of iron, see the carbon dioxide intensity. Per ton, it is about 2.25 ton. And you see, this is basic oxygen furnace. Then you can, then with biofuels, in direct reduced iron, you can go with 0. So what it means, that steel industry, which is highly polluting, and India plans to have something like 300 million tons of steel, this is the time we invest in this green hydrogen and go to that, so that it becomes green steel. Okay. So there are many ways by the industrial production is done of hydrogen. Steam reforming of natural gas is the topmost, and there are others as well. Okay. So we did, like others, we did a lot of research on blue hydrogen production using, for example, ethanol, methanol, ethylene glycol, glycerol, and butanol, whatnot. We published also. Okay. But what we developed later is the IC. I've been working in this area since 2006. So we developed, and my work is supported by ONGC Energy Center. We can produce hydrogen at 95 cents per kg. And what the government is saying, even Niti Aayog, Dr. Amitabh Kant said 2 days back, we can produce hydrogen at less than $1 by 2030. Because Ambani is also saying that. And we are talking about this new policy, right? And once we have hydrogen, then hydrogen fuel cell, electricity, e-vehicle, whatever, we can do that. So why important? Because it is from water. Water as a feedstock. And hydrogen has the highest specific energy in comparison with wood, ethanol, coal, you name it. Hydrogen has the maximum. Okay. And there are many means of production of hydrogen. Okay. So you require some energy source, right? And so the cost of hydrogen depends on the cost of electricity. So whether you talk of solar, photovoltaic, or whatever. So we have thermochemical, electrolytic, and photolytic hydrogen production technology. Natural gas steam reforming is 95%. Then biomass gasification, pyrolysis, all sorts of things are there. And then we are talking about solar hydrogen. So solar, and people are a lot of work. Once again, you see that carbon monoxide going to methanol, and air separation to ammonia, all these chemicals, whatever I told you before, all that. That means you require some source of energy. So now if we compare the reforming technology, steam reforming, as I mentioned to you, is the most preferred one right now, but it has highest carbon dioxide emissions, right? So in our case, we looked at copper chlorine cycle in this, and we also did initially sulfur iodine, but now this is done by IIT Delhi. Sridev is doing it. But copper chlorine cycle, we worked on that, and we got several patents on this copper chlorine cycle. So we said, what is the technology maturity of what we are doing? Steam reforming, I mentioned. See, efficiency is in the range of 60 to 70, 85%, which is commercial. Same is biomass gasification. Same is alkaline electrolyzer. Okay. These are mature. So in this mature technology, steam reforming, electrolysis, and the byproduct hydrogen ion industry, or in our caustic industry, you get hydrogen. So our focus in this so-called future technology. So what we did, we looked at all available data, patented data, and natural gas, coal, all these things, and we looked at the capital cost and the hydrogen cost. So you see that this particular table, you can take these numbers as just a rough estimate, calculation based, anywhere between 1.34 to something like, you go 10 also. You can see there something like 10.49, 23, depending on is a solar photovoltaic. So cost of this hydrogen, clean hydrogen, is very important. So in our ICT OEC process, we have solar energy plus thermochemical. We can produce at 95 cents, but provided I produce 100 tons of hydrogen per day. So when we do this well to get greenhouse gas emissions, you see renewable hydrogen is 0. Steam reforming of natural gas 9 kg per kg. Carbon capture 90% or 56% will be 1 kg of CO2 or 4 kg of CO2 per kg. And these natural gas prices which were taken, typically the capacity's cost is $730 per kilowatt. That is the magic number. Okay, this is based on data which I collected. Okay, so look at the electrolyzer cost. 1100 in 2020 per, then 550 they say 2030 it will go to 220, 2040. So it is going to fall down. But the carbon capture and storage, that will increase. And right now it says anywhere between 990 to 1850. So low carbon fossil based hydrogen cost will be about 2.5 to 3. And this is the magic number all researchers and companies are targeting. And green hydrogen, they say, should be in this range. And for that, the solar electricity has to be cost competitive. And so if you have the installed PV power, and if the cost is reduced, something like say $5 per watt to something like $1 per watt installed, then the cost of electricity is predicted to reach about 0.1 kilowatt. So in other words, when that happens, remember, these data are, I've taken this from International Energy Agency. See that when you have zero carbon production, electrolysis, and the hydrogen cost in euro, see it is from $8 a euro to it is going to be in the range of 2 to 4. Okay, the capacity is going to go up to 30. You see there are 14,000 here, 1,400,000, 1,40,000, and you see from here 500 the cost, per kilowatt. That should go to below to something like 30. Okay, the hydrogen storage technology will improve. Then the fuel cell technology will be there, and hydrogen fueling stations will be there, and then fuel cell vehicles. So you will have two types: two-wheeler, three-wheeler, four-wheeler, and the big trucks and all those things. Two-wheeler, three-wheeler, four-wheeler, they will be electricity based, but the electricity that is based on hydrogen fuel cell. And the other can be directly hydrogen because it requires longer distance. You require a lot of hydrogen storage. Then you will have refueling stations when you have, this fuel cell based thing. So ultimately, what it means, the cost of this hydrogen in the future, it has to be less than $2, including operation and maintenance. So that is our magic number. And so by 2030, hydrogen economy will be a reality for all over the world because International Hydrogen Council is working very vigorously. A lot of people have joined, companies and others, nations have joined that council. So once we have hydrogen, we can use for transportation, we can create syn fuels like carbon dioxide to hydrocarbons and whatnot, methanol, ethanol, etc. Upgrading of oil, biomass, ammonia, green ammonia, metal production, chemical and industrial processes, part of it, and heat and distributed power. So long as we produce hydrogen and then we produce electricity also, it can be taken to the grid. So that is the benefit of the hydrogen economy. And according to McKinsey, they have said that these are the major sectors, whether it is power, transfer, industrial, ecology. See, their bubble size indicates the hydrogen potential. And this potential is going to be very high. Something like predicted 10-fold increase by like 539 million metric tons hydrogen will be required. So remember, existing uses, whether ammonia, or all this methanol industry and whatnot, you will see that this is what is going to happen. So ultimately, in the net carbon negative fuels, net zero goal will be achieved only when hydrogen is used. And so carbon dioxide refineries of the future, what nature is doing, and what we can do with hydrogen. So hydrogen is the key, and so methanol, Dimethyl ether is the best substitute for diesel, and also LPG. So the same infrastructure can be used. So we don't have to use build another infrastructure. Yes, for hydrogen we'll have to build infrastructure. So this is very important. So in my laboratory, what we did, and we got several patents, is we have a solar power which we use through molten salt. So we developed some new compositions, and we have got patents on that. We use water copper chlorine cycle, which is internally recycled. So produces hydrogen and oxygen, and biomass can be hydrogenated or oxygenated, I told you before, and our carbon dioxide to methane and higher hydrocarbons, our waste biomass, plastic. So you the kind of products which we can produce. A lot of this work we have done in our lab, including hydrocarbons, methanol, dimethyl ether. And dimethyl ether, I've sold this technology now to our Godavari biorefinery. We're going to sell it together now because they produce a lot of carbon dioxide. Methanol, ONGC has decided to support me, and we are going to have a plant in Goa now, a big pallet plant where hydrogen and also carbon dioxide, and this will be used. Okay, so all these things, whether fuel cells, hydrogen vehicles, and I've been claiming that, and since I've been claiming since 2015 that we can produce hydrogen, provided the minimum capacity is 100 tons per day. So this is our process anyway. So ultimately, some philosophical thought: can we create a zero waste society? Because we are exhausting all our materials and whatnot. So reduce, reuse, recycle, recovery, everything is possible. By 2030 or by 2050, when we are talking about net zero, can we have a net zero waste society? Very good question, right? And this is where they talk about the circular economy. I won't go into the details of that, but ultimately come to the role of hydrogen. That hydrogen will play a very important role in circular economy. That is what the take-home point I'm saying. And so then circular economy, everything. This is the Ellen MacArthur Foundation. So they have given this. So the green hydrogen economy, bioeconomy, circular economy, they are all interlinked. Okay, they are all interlinked. So we can see that everywhere the cascades are there, recycle, reuse, all those things, including materials, biomaterials, name it. Everything is, you can see this recycle, refurbishing, redistribute, maintain, all those things. Okay. So ultimately, in the hydrogen economy by 2050 scenario, you see that regional trains, heavy truck duties, medium truck duties, vans, coaches, ferries, taxi plate, all these will be based on hydrogen. There will be a lot of new hydrogen applications. Okay, and there will be you have simple cycle turbine, combined cycle turbine, all those things, and existing steel, ammonia, methanol refining, that will also be there. So imagine that the hydrogen economy will, as I said in the beginning, will be the savior of the world. So yes, so we go to finally hydrogen safety, because some learned journalist wrote, by their nature, all fuels have some degree of danger. As you will agree with me, the safe use of any fuel focuses on preventing situations where the three combustion factors like ignition source, oxidant, and fuel are present. So we have to take care of it. So number of hydrogen's properties make it safer to handle and use than the fuels commonly used, including petrol. Hydrogen is non-toxic. In addition, because hydrogen is much lighter than air, 14 times lighter than air, it dissipates rapidly when released, allowing rapid dispersal. And already experiments have been done and tested hydrogen system. Tank leak test, garage leak simulation, hydrogen tank drop test, all of them have shown that hydrogen can be produced, stored, and dispensed everywhere. And I will also tell you, one of the things that my friend Trevor Kledge used to say, because he wrote on safety and all that, he said in his analysis of industrial accidents in chemical industry, hydrogenation was the least. It was not even shown in that. So this hydrogen is handled by chemical industry very nicely. So green hydrogen is safer than conventional fuels. That is the conclusion. So finally, I must quote Swami Vivekananda. Each work has to pass through three stages: ridicule, opposition, and then acceptance. So people will accept hydrogen as a energy carrier, fuel, and whatnot. Okay. So the way forward is green hydrogen will be the savior of the world. CO2 should not be a liability but an asset to convert into a variety of things. Hydrogen economy can be elegantly intertwined with to make many chemicals, waste carbon sources including C1 gases, and government of India should adopt hydrogen economy. And ICT OAC, which is my technology, is one of the promising technology. I'm not saying it is the only one, many others may have them, but yes, I can definitely say that yes. So hydrogen, and carbon dioxide refinery, biomass conversion, that is the only way to meet the goals of Paris Agreement, and we can make it. Thank you very much. So this is the lecture you invited me to give this talk, and I'm very happy that I could talk about my research which we have been doing in our laboratory. Thank you very much, and I'll be very happy to answer any questions you may have.
So, Professor Sharma, actually, you can take up any questions. Professor Sharma? Please.
Yeah, you have any questions? I'll be happy to answer.
Yes, sir. Madam, I have a question. Not a question, but a query. This is Dr. Patnaik from the Shiva University. Yeah. So, sir, this has been a very, very interesting talk on the power of hydrogen. Maybe very sooner we will be having hydrogen bomb in the country. One of the earlier talk was silicon in this series. Now this talk is on hydrogen. So it appears the future is only silicon and hydrogen centric. So, sir, my query is that in spite of all these achievements we have in this chemical technology in the country, could be producing hydrogen or could be biorefining, but biorefining may challenge food security in the long term. So my query is that in India, where do you stand in hydrogen economy? You have started adopting it or just thinking to adopt it? Because finally hydrogen going to, you say the hydrogen is the source of power for everything, could be electricity, whatever power, the hydrogen economy. So in India, where do you stand in the policy making level? And how soon you are going to adopt it?
I'll answer your question. This hydrogen is not hydrogen bomb. That hydrogen bomb is deuterium and tritium. Okay, that is what you should know. Okay, hydrogen is much, much safer. Number two, food versus feed you mentioned. Any waste biomass can be used, and that debate is already been taken care of. Whatever food we require, you waste so much that carbon which is being wasted as a waste, including the grass and trees and whatnot, that can be used to convert into chemicals and materials. And hydrogen is coming from water, okay? So there is no problem. Yes, silicon was said because silicon is 27% in our request. So silicon is used, like silicon is used for making materials like silicon carbide, silicon nitride, and many other silicon chips and all. But why I talked about hydrogen, because according to me, when we do not have any, crude oil or coal, our coal will not last more than 200 years. Okay. And again, the quality of coal. So if you want to use coal, you have to have underground coal gasification and make, carbon monoxide and hydrogen syngas, and that convert into some chemicals and materials. Okay, that is another way of doing it. But when we do not have a, economic way of excavating or extracting crude oil from, that is why I showed in the beginning, the crude oil, this oil recovery methods, we have to go for some renewable source of carbon, and that is biomass. Okay, so and then it becomes carbon neutral. That is the way I look at it. And so long as we produce hydrogen at a cheaper rate, and this is going to happen, believe me, across the world. When initially this crude oil, the petroleum refineries came into being in 1910 and 20, and at that time, they had a problem of distribution. Okay, so the fuel tanks and the petrol pumps and all, that infrastructure was built immediately. So even in the case of hydrogen, the infrastructure will be built but we have to invest in that. Our government is saying by 2030 we will have e-mobility, we will have this and that. Unless we prepare right now, develop technology. Nobody is going to give the technology. I'm telling you right now also, we are in limbo. The cost of petrol is going up because of this war, Russia and Ukraine war. So if we have our own source of energy, where we have huge quantity of waste, we can be self-reliant. See, solar, wind, government of India is right. Okay, and then you add hydrogen, because why I said hydrogen? Because chemicals and materials, hydrogen is required. The solar will give energy. Hydrogen as a carrier will give energy, but the other part which is required for our so-called biorefineries and all, that is hydrogen and oxygen, which is coming, and oxygen, and I gave you a list of chemicals and what can be made without going into the details. But yes, hydrogen economy will happen. In fact, I've been writing to the government for the last 4 or 5 years now. Hydrogen should be promoted, the Prime Minister's office and all. I wrote to Dr. Vijay Raghavan. And so he has listened to my lectures also. Dr. Kaporkar has listened to my lectures and all this. And according to me, we should be leaders rather than being followers. The ammonia policy, Germany is already doing, because ammonia is easy to carry. The pipeline of ammonia is there in Germany, and so you split it and get hydrogen and nitrogen. Nitrogen goes at inert. Yeah, so it is happening across the world. So India should not be by 2030, within next 4 or 5 years. Right now also, Ministry of Petroleum, the secretary came and met me twice. They said how much money you need. We will give it, but you make it. And there are many others. It is not I'm the only one. There are others. They said, let us develop this technology. And then they first use, like you suppose we are going for 330 million, 300 million tons of steel. Hydrogen can be produced there only. That CO2 emission will go down. So we are also kept our part of that commitment to Paris Accord, Paris Agreement. So these are all interlinked problems, and the government has to come in to support research, pilot plant data and all. See, I don't have space on my ICT campus in Matunga. It is only 16 acres. So I'm going to Goa. ONGC has given me a site in Goa where we are, taking all this pilot plant, and reinstall there, recommissioning. So it is not that government is interested, industry is also interested. But I will tell you, technology is not developed overnight. We have to put in a lot of efforts in this.
Thank you, sir.
Thank you so much, sir. I don't find any questions in the chat box. If anybody wants to ask question, they can raise the question by unmuting themselves.
So Yadav, I had a very small question.
Yeah, please go ahead.
Can ammonia be used as a fuel?
Yes. Ammonia is
better than
it is better because it is better than storage wise. Ammonia is better actually. That is why Germany is promoting that. But only thing is ammonia is corrosive also. You remember?
Yes, it is corrosive.
Yeah, it is corrosive. But you require a catalyst. Like nickel-based catalysts are available, so you can split ammonia and make hydrogen and nitrogen, and that is what is being developed. A lot of work is going on in Germany and rest of the world.
That's why possibly they put it green hydrogen and green ammonia together.
Yeah. No, and one of the things which I told that when we were doing this carbon dioxide to methane and ethane and others. So I said the so-called synthetic methane, where you have combination of hydrogen 10%, 20% plus methane. That's a very good fuel. Okay, Indian Oil is doing it in Delhi. They have some buses. So I said I can produce that. You don't have to mix it. I can produce that 10% hydrogen and 90% methane, because our catalyst, which we have patented now, gives without any problem 2,000 hours no deactivation of the catalyst. So we know. So what we have done. So in Goa we will have hydrogen production. We will have fuel cell. to generate electricity because we can't store hydrogen, and also use that hydrogen for carbon dioxide to methane and all. That is what we are going to do now.
Thank you so much. Thank you so much, sir. Now I request our Pro Vice Chancellor, sir, Professor P.K. Nanda, sir, to give vote of thanks.
Ma'am, may I ask you a question?
Yeah.
One.
Yeah, please.
Good evening, sir. I just want to know, already I have listened to the complete one, so most of the things are very new to me. But I want to know whether the infrastructure needed for production of hydrogen will be more, or the infrastructure needed for storing and detection of it, because it is just like gasoline, gasoline. It is not detectable just by smelling. So you have to implement some techniques to detect it. So which cost will be more, whether the production cost will be more or the storage cost and detection cost?
No, I tell you, we have powerful sensors, this so-called Industry 4.0. These are not the old timers when you did not have sensors. Now very powerful sensors are available. So immediately if there is any leak, it can be detected and action can be taken. And that has been already done by many of these companies. This like Toyota and all these companies, they have done experiments and they have done it. Okay, so that's not a problem. They know how to stop that. Number two, the infrastructure for transportation and storage, that is very important. For example, should hydrogen be stored in big tanks, and what should be the size and all? What should be the mileage? What pressure it should. These are the activities which already these buses which are being run in Korea and California, they have done a lot of work, and in fact 5-6 different companies are working on that. Okay, because if you want to go say 300 kilometers or 400 kilometers, you require a tank where it is having that thing. And hydrogen energy is 2.5 times more than the petrol which you store there. Okay, that is another plus point with hydrogen. So yes, infrastructure will take, initially it will have some problem, but as you know, it happens with all technology. When it is introduced, like these mobile phones, you have problem of the towers and all. Now mobile phone, this cost went down day by day. So that kind of thing is going to happen here also.
So it means the recurring costs will be less.
Yeah, it will be less. The production, if you increase the production capacity, the cost, that is the economy of scale, isn't it? See, when I say $1, I say it is minimum 100 tons you have to produce. If you produce less, then the cost will go up. It may go to $2. And interesting part, 1 kg of hydrogen gives me 8 kg of oxygen. And our international price of oxygen is 10 cents per kg on bulk production. So I get 80 cents credit of oxygen. Okay, it's very interesting.
Thank you, sir. Thank you.
So if there is no question. Yes, Prasananda, please.
Sir, good evening, everybody. It was quite gratifying to listen to the stalwart and the eminent scientist, chemical engineer and researcher, and also nation builder, Professor Ganpati Jadhav, who is also our board member, our advisory board member, who has advised us time and again. And rightly, he has kind of shed light on a very contemporary research issue, and also the threat to the whole humanity, that is the climate change we have been witnessing and also we have been experiencing. And last October, the kind of the Glasgow Convention also everybody vows, including our Honorable Prime Minister, 2070 will be carbon free, emission free, and I think it's quite pertinent and the contemporary thematic area of concern for the whole humanity, and not only humanity as a whole planet, because everybody is affected by that. And we are looking for reducing that carbon emission, and as a result there will be improving the climate conditions and alternative source of energy, which is a threat to the whole humanity. And Professor Jadhav has rightly, I think, said like the whole gamut of like 200 years of evolution of energy, and yes, there is going to be a paradigm shift in the energy use and the production and the consumption. Question of technology, question of challenges also he has posed. I wish that this kind of technology, his experience, whatever, India will be one of the leader in this field, and instead of the kind of we have shortage of the crude oil, so therefore this will be alternative to meet these challenges and make this humankind a better place or a planet a better place, and particularly India in a moving forward and a global player in this country. I think it is very illuminating and kind of the motivating, and also touching upon the contemporary research. So on behalf of INAE Bhubaneswar chapter and SOA and IMMT, I would like to extend hearty thanks to Professor Jadhav, who has spent so much time in illuminating us about this kind of crisis and evolution about this and solving this threat in future. I also thank Professor Damodar Acharya, who is actually spearheading this kind of activity and also is helping many of us to have open our eyes to the different issues, global issues, and also the local issues. I think Professor Basu, of Director of IMMT, who is always in this webinar and sharing his kind of the research of this institute, and Professor Ashok Mahapatra, who is also with us, and our Vice Chancellor, who is sharing his expertise here. I thank Dr. Renu Sharma, who is coordinating for every event, every time, his team. And I thank all the delegates, all the participant, distinguished personalities who actively participated in this kind of talk and also make it a success. Thank you, everybody. Have a good night, good day, good night.
Thank you, sir. Namaste, sir. Thank you for joining.
Namaste. Thank you.
Namaste, Professor Yadav. It was so excellent.
Thank you. Thank you so much.
We'll send a small memento to you by post.
Okay, no problem. Thank you. Thank you. Thank you. Okay, bye-bye.